Hello, we decided to do a project that is capable of hand-drawn ER diagram recognition. My name is Alan, and I am presenting with two fellow group mates, Tommy and Josh. Josh will start us off with some background and context.
Originally, we wanted to do Where's Waldo because it seemed like a fun idea to do. However, we quickly realized that this was much more difficult than we had first anticipated. Even the best machine learning algorithms were not capable of reliably identifying Waldo, so we decided to come up with a different project. The three of us were taking a database class at the same time where we were learning about ER diagrams. We thought it would be cool to create a program that could recognize the different components in a hand-drawn ER diagram. What is an ER diagram? It is an entity relationship diagram, a type of flowchart which shows how entities interact with each other. They use a defined set of symbols, shown on the right, such as rectangles, diamonds, ovals, and lines to illustrate how these objects interact with each other. ER diagrams are most often used to design a relational database, a type of database that stores and provides access to data elements which interact with each other. This is an example of a basic ER diagram. There's a scientist entity and an invention entity, each with several attributes such as name and ID. The relationship is that a scientist invents an invention, and this diagram was crafted using a tool. But our goal is to be able to identify entity, relationship, and attribute symbols in a hand-drawn ER diagram. Alan will now elaborate on this further.
The goal of our program is to recognize and identify the previously mentioned symbols in a hand-drawn ER diagram. To help us achieve this, we make a few assumptions. First of all, none of the objects drawn should be directly touching the border of the image. A human should be able to recognize the shape that is drawn. The shape should be resembling the shape they are intended to be. The shapes must also be enclosed so that there are no gaps in the perimeter of the shapes. And finally, the input images should be made using Microsoft Paint. The last 2 points will be elaborated further by Tommy a bit later. The logic of our program can be boiled down to 3 steps. The first step is to prepare the image to find all the contours. The first image shown is the original input image. We convert this image to grayscale in order to account for colored images. Then we use a threshold function to create a binary representation of the image so that it is represented purely in black and white. From there, we can use OpenCV's find contours method, which stores all the contours found in the threshold image. We are now ready for the next step. The second step is to detect the shapes. From the previous step, all the contours are now currently stored inside a vector that was populated using the find contours method. Each contour is then analyzed to determine the shape, which is used to determine the symbol that the contour represents. Contours are then analyzed based on various properties, including location, number of vertices, and so on, and if it is recognized as a symbol, it is stored in the appropriate vector. Now on to step 3. Step 3 is to finally create the output. After each symbol is stored in their respective vector, each symbol is boxed and labeled on a copy of the original image. You can see an example of this to the right. Each symbol's box color and label depends on the symbol. In the example to the right, that diamond shape is the symbol for a relationship between two entities. Therefore, it is labeled as a relationship, and our program draws a green box around it. When our program is displaying the output, the original image is displayed alongside the labeled image. Tommy will now demonstrate a few example inputs.
The following slides will show examples of ER diagrams we created for our program. This one is a basic ER diagram. It has 2 entity objects, as shown with the rectangles, and 1 relationship object, denoted by the diamond shape. And here are the results after running it through our program. As shown here, the 2 entity objects are boxed in by blue, and the relationship object is boxed in by green. Here is the advanced ER diagram we created. This ER diagram is an example of one of the ER diagrams we created in our database class. With this ER diagram, it contains all of the elements we found most important to be in the ER diagram. This ER diagram would closely resemble a diagram that would be made in an actual project. And running the ER diagram through our program, we can see that everything was able to be labeled and boxed in correctly. One thing to know was that the weak relationship object that is boxed in by the lighter green color was distinctly made so that the object itself looked very bad. As you can see, the diamond shape itself is drawn very skewed to the right, but our program was still able to identify it without a problem. On to some issues we ran into. The first one was that the program can't recognize severed shapes and unconnected diagrams. An example of this would be the lower left image on this slide. The second problem was that the total participation would sometimes get recognized as an entity. This issue arises because the total participation line would sometimes be drawn to look like a rectangle. The third problem was that test image had to be made in MS Paint. Now this one was interesting. As you can see with the two screenshots in the lower right of the slide, the left one was made in MS Paint while the right one was made in Microsoft Whiteboard. With Microsoft Whiteboard, it created more contours than the one that was made in MS Paint. Since our initial test images was made in MS Paint and our code revolved around testing those images, we didn't consider that the image would have a different number of contours depending on what application we used to draw it. And then the fourth and last problem was the scale of the input image. Since the program uses weights to label objects, the input image cannot be too big or too small in dimensions.
So what's next? First of all, we want to be able to recognize more diagram symbols. For example, total participation and composite attributes. Recognizing total participation would also fix one of the issues mentioned on the previous slide, where currently total participation sometimes gets identified as an entity. We also want to handle non-supported types such as triangles. Triangles do not represent anything in an actual ER diagram, and we don't want them accidentally getting classified as something legitimate. A very practical feature would be able to handle severed shapes. Since we are working with hand-drawn diagrams, it is highly likely that some shapes in the diagram are going to have gaps. Since ER diagrams are all about relationships between entities, it would also make sense that our program should be developed to recognize which types are related. Building off that, a step further would be to construct the resulting relational tables. However, that would require recognizing someone's handwriting. Assuming we could implement that, though, that would make this program a practical product that could be marketed to the public. We hope you enjoyed our presentation as much as we had fun developing these two projects. Thanks for listening.